Hello everyone, very good evening and welcome to the BYJU'S Exam Prep, the most comprehensive app for all exams. Let me know that sound quality, picture quality, everything is fine. Now in this session we are going to discuss what reciprocity, or that is called reciprocal, Tellegen's theorem, and what duality. So what is the reciprocal network, what is the reciprocity theorem, Telegraph theorem, and what is the duality. We will discuss each and everything. Let me know that sound quality, picture quality, everything is fine. And then it is on BYJU'S Exam Prep. This is for GATE 2023, and that is the important topic from network or circuit theory. And this session is important for electronics, electrical, and instrumentation branch. So I think that sound quality, picture quality, yes please. Okay, now everything is fine now. Now that is my introduction. Myself Sanjay Rathi, 21 plus years of teaching experience in the field of competitive exams like ECE, GATE and PSU. I have qualified and selected for engineering services exam. These are my ranks: AIR 16 in ECE 2005 and AIR 21 in ECE 2008, and I have mentored more than 1 lakh students for these exams. Okay, now this is for you, 90% scholarship on GATE preparation program. Please note this date on 15th May 2022 at 11 AM. Right? Register now on BYJU'S Exam Prep. Install this app. Okay? And then today's topic, what is the reciprocity theorem? Today we are going to discuss one reciprocity theorem. After that, Elegance theorem. Elegance theorem, this is important. And third one, that is duality. No doubt, according to your perception, that a Thevenin's theorem, Norton's theorem, superposition theorem, right, and what maximum power transfer theorem, maximum average power transfer theorem, these are important for what a GATE exam. But you can also solve the question by using these theorems. Okay, these are also important. I'm going to give you some important concept. I'm going to solve some important numericals and with short tricks. Okay then. So please join the session. Everyone, please join the session. That is, I think that is visible to you. Okay then. Reciprocity theorem. Now, what is the meaning of this? In any linear bilateral network, and this is a keyword. Always remember what will be the keyword: linear bilateral network. If a single voltage VA produces a current IA in a branch B, that is the IB in branch B, this is the A, that is the B, then if the voltage source VA is removed and inserted in branch B here, will produce a current IB in the branch A, the ratio of the response to excitation. Ratio of the response. Response means output, excitation means what? Input. Output upon input will remain same for the two conditions mentioned above. This is called reciprocity theorem. What is the condition? Linear bilateral network. Okay, then that theorem is applicable. Simple. Let try to understand this concept. Just I am giving you the very simple concept. Let this is the V1, this is the part of network 1, let this is the port 1. Here we are considering the I2, this is let I1. I am changing the position of the voltage, let this is the V2. Let the current in this branch is I2. We are changing the position. This is called excitation, this is called response. That is called excitation, that is called what? Response. Then according to reciprocity theorem, I2 by V2 from the second diagram is equal to what? I1 by V1. Response upon excitation will remain same. Okay, output upon input will remain same. So that is the reciprocity theorem. Okay, now we are going to solve some numericals on this. Then second, just I want to give one example on this network. Try to understand this. Okay. Now, simple, I'm going to explain T network. For example, very simple T network. Right, this is the T network. For example, let this is the R1, this is the R2, this is the R3. Okay, this is simple T network. Now suppose I am giving the input here. Let I am applying the 10 volt here and I am getting the current across this branch 2 ampere. Right, then what will happen if suppose I am changing the position here? Suppose I am changing the position here, same network, we have no idea about the values of this R1, R2 and R3, but if it is purely resistive network, means it is a reciprocal bilateral network. Now I am changing the position of the voltage source and current source. That is the case. It is let 5 volt. What will be the current in this branch? That will be the question in GATE exam and in other competitive exam. This type of questions from the reciprocity theorem. Okay, very simple question. What will be the answer? Everyone please give me the answer in comments box. This is a very simple question. What will be the answer? That is the response upon excitation from the first diagram 2/10 is equal to response upon excitation from the second diagram, and this I will become 1 ampere. This is the I will become 1 ampere. That will be the answer. Okay, very simple reciprocity theorem. Now second theorem is what? Telegen's theorem. So what is the Telegen's theorem? The Telegraph Theorem states that in any arbitrary lump network, the algebraic sum of the powers in all the branches at any instant is what? 0. Yes, Niranjan, your answer is correct. In any arbitrary lumped network, right? So any type, whether it is a bilateral or linear or non-linear, unilateral, any network, that theorem is applicable. But always remember, you have to satisfy what? KCL, that is the Kirchhoff's current law, and Kirchhoff's voltage law. This is very important theorem, and we can simply write it like this: the power across any branch Pi, I is equal to 1 to what n, let there are n number of components, the summation of this power is equal to what? 0. P1 plus P2 plus P3 plus P4 and so on Pn, that is equal to what? 0. Now to understand this concept, always remember one thing. For any element, for example, these are the elements I am giving you, there are 4 conditions. Everyone give me the positive and negative value of the power. Right. Let this is any element, it may be resistor, it may be voltage source, it may be current source, capacitor, inductor or anything. Let this is the voltage across this element and that is the direction of the current. Then what about the power? Similarly, this is the voltage across the element, that is the direction of the current. Then what about the power? Delivered or absorbed? This is the first case, second case, third case. This is the plus, this is the minus, this is the direction of current I and that is the V. And fourth case, that is the I, this is the V. Now, in third case and in fourth case, what will be the power, everyone? Now, very simple concept, we have to use this type of concept. Simply, in this case, the power will be positive. Positive means this element will absorb the power. If the current enter through the plus, leave the minus, then the power will be absorbed. In the second case, again the power, try to understand, current enter through the negative, leave the positive. Enter through the negative, leave the positive means power is minus Vi, or if there is a negative means power delivered by the element, delivered by the particular element. Okay, it may be voltage source, it may be current source, it may be capacitor, or it may be what, inductor. When the capacitor will discharge, it will give the energy. When inductor discharge, it will give what, energy. So that is the case. So always watch the polarity of the voltage and direction of the current. Similarly, here the current enter through the negative, leave the positive. What will be the power? Enter through the negative, leave the positive, minus Vi. Delivered. Power delivered by the element. Okay. And here the P is equal to Vi. Again, enter through the plus, leave the minus, and that's why absorb. So that is the condition to satisfy the Telegen's theorem. Okay. Now, so these are the four cases. Always remember, if we are getting the positive, means power is absorbed or dissipated. Dissipated means across the resistor always the power is what, dissipated. But what about the nature of the capacitor and inductor? It can store the energy, right? Capacitor in its electric field and inductor in its magnetic field. Okay, so that will absorb. Absorb means it may be stored or it may be what, dissipated. Normally across the resistor the power will be dissipated. That is the case. Now this is the Telegen's theorem, and that what is the important point about the Telegen's theorem is based on two Kirchhoff's laws and is applicable for any lumped network, having elements which are linear or non-linear, active or passive. This is important. Time varying or time invariant, and it is completely independent of the nature of elements and is only concerned with the graph of the network. This is very, very important point. Only the graph of the network. There is a one topic that is called graph theory. Okay, this is very, very important topic, that is the graph theory. Here we are learning about the T, or what that is link, what are the twigs, what are the link, what are the chords, right? Tree, right? These are the concept here in the graph theory. We are learning about the tree, cut shut schedule, tie shut schedule, different equations, number of branch and loops and so on. So this is the tree, cut set, tie set, link, chord. These are the important parameters in what, graph theory. Okay, that is the Telegen's theorem. Now I think you are ready to solve some questions, everyone. यार एक बार जरा please like the session and subscribe our channel, that is BYJU'S Exam Prep, and share the link of this session. Okay, again that is not mentioned in the syllabus of the GATE exam, but this topic is important, how to calculate the power, what is the summation of the power and so on. Last one is what, duality and duals. If you want to draw the dual of particular network, we are using this concept. I will solve one question on this. Some pair of dual, current is replaced by voltage, open is replaced by short circuit, inductor is replaced by the capacitor, resistor is replaced by the conductance, or 1 by R, G, right? This is called what, G, that is the conductance. This is the 1 by, when I am writing the 1 by R, that will confuse you. I am simply saying that if it is a 2 ohm, it will convert it into a 2 ohm. That is the case. Series is converted into parallel, and voltage source is current source replaced by the current source, and KCL. When we are applying the KCL, now we have to apply what, KVL. That is the duality. चलिए आते हैं, वेरीफाई द रेसिप्रोसिटी थ्योरम फॉर द नेटवर्क. व्हाट इज द वेरिफिकेशन, हाउ वी कैन वेरीफाई इट? एवरीवन, दैट इज वेरी वेरी सिंपल क्वेश्चन. If this is the 100 volt, what is the current in this branch? Here you have to find. This is the 100 volt, what will be the I1? What is the verification means? Again draw the diagram, same diagram, but change the position of voltage source. Try to understand what is the verification. Like this will act as short circuit. Circuit will remain same. This is the 4 ohm. This is the 4 ohm. Now here I am connecting the 100 volt battery. 100 volt battery. This is the 4 ohm. This is the 4 ohm. This is the 12 ohm, 14 ohm, and that is the 3 ohm. Now what will be the I2 here? In both the cases, if the voltage are same, the I2 and I1 will remain same, because that network is what purely resistive network, and that's why it is a bilateral, right? It will satisfy the reciprocity theorem. So you can find the value of I2. This is a very very easy diagram, or here we can find the I1. In both the cases, I1 and I2 will remain same. That is the use of what? Reciprocity theorem. Okay, now second one, we are having the similar type of questions here. Everyone try to give me the answer for this question. Very basic question on reciprocity theorem. Watch this. This is the 10 volt battery here. Try to understand. This is the 10 volt battery here. 2 ampere current here. We have no idea about the R1, R2, R3 and R4. Unknown resistor are connected here. But when the 10 volt is connected here, we are getting the 2 ampere. Change the position. What will be the current here if the 20 volt is connected here? Simple. When the 10 volt is here, 2 ampere. Now we are connecting the double value, 20, double. Same polarity. What will be the value of I? What is the answer? A, B, C, D? Tell me. Then from the first figure, 2 by 10 is equal to second figure I by 20. 2 by 10 is equal to what? I by 20. That what will be the current? I is equal to 2 into 20 divided by 10. That is nothing but 4 ampere. D is the option. D for Delhi. Okay. Means in this type of questions we have to use what? Reciprocity theorem. It is a purely combination of what? Resistor, and that's why it is a reciprocal network. Okay. Then that is different types of cases here. Maybe cases we can satisfy. For example, if, like, try to understand, if that answer is reversed, that arrow is reversed. In first case, the arrow is downward. Always watch this arrow. In second case, I am using the arrow upward. Then what will be the answer? Always remember, this is the 2 divided by 10. In this case, it will become minus I, because the direction is reversed. Minus I divided by 20. What is the I is equal to? Minus 4 ampere. Watch the polarity. Watch the polarity with respect to this diagram. Always. Third case, it may possible, they may change the polarity of the battery. For example, if this is the case, we have no idea about the resistor, but this battery polarity is reversed. Everyone, what will be the answer? This is the 20 volt. You have to find a current here. Compare with the figure A. This is the figure C. Or you can compare with that. So what is the, here the, this is the 10 volt battery, here the 2 ampere. But I am changing the polarity. That polarity is reverse and the direction is downward. Then again you have to write 2 divided by 10 from the first figure, 2 divided by 10. Now this is the same current I, but this time the battery is negative, minus 20. And that's why again I is equal to what? Minus 4 ampere. Means you have to take precaution. You have to take the precaution that what will, watch the, read the question carefully. what is the polarity of the battery, what is the direction of the current, then you can give the right answer for particular question. Try to avoid the silly mistakes in any question, right? Try to avoid. Okay, I think this is clear. Now, everyone give me the answer for this question. This time we can get what? MSQ also, multiple select question in GATE exam. Multiple select question in GATE exam. Okay, so watch this question. The theorem which states that in any linear, non-linear, passive, active, time variant, time invariant network, the summation of the instantaneous power is zero will be called as. Right? So that is the reciprocity theorem. Already I have given superposition theorem in previous class. We have discussed that compensation theorem. That is in the syllabus of what? Engineering services exam. Now this is the Telegen's theorem. Answer for this question is simply Telegen's theorem. This type of questions, theoretical questions from this topic. Okay, Telegen's theorem. This is important. So always remember what is the statement. The same statement they may give in what? GATE exam, like option A, option B, C and D, which are correct. MSQ means multiple correct answer, multiple select questions, A, B, C, D. These type of questions are very, very important. Read these questions: linear, non-linear, passive, active, time variant, time invariant, and that is that is the statement of Telegen's theorem. Okay, Niranjan. Now I think this is clear. Now that is the question. The power dissipated in 1 ohm resistor is 1 watt due to the 5 volt voltage source alone, and 576 watt due to the 30 ampere current source alone. The total power absorbed in the same resistor due to both the sources is. Right? Now here, that is the question based on superposition theorem. Tell me what will be the answer, everyone. The power dissipated in the 1 ohm resistor is 1 watt due to 5 volt. If I am connecting the 5 volt battery, what is the power dissipated across the resistor? 1 watt. And due to 30 ampere current source, power is 576 watt. Everyone give me the answer. What is the answer for this question? 577 watt, 575 watt, 625 watt, 529 watt. Yes, please, in comments box. This is very, very simple question that is based on superposition theorem. So in a single, it may be any type of network. Due to the 5 volt voltage source alone, 576 watt. Due to the 30 ampere current source alone, the total power absorbed in the same resistor is what? This much. Then we can also draw the network. If suppose you want to draw the network, okay. This is the resistor connected here. This is the voltage source here. There is a current source here. Because of the voltage source of 5 volt, what is the power dissipation? 1 watt. And because of the current of 30 ampere, what is the power dissipation? 576 watt. Then what will be the power? Okay. Now, give me the answer in comments box, everyone. If suppose you are giving that 576 plus 1 watt, 577. In previous class, superposition theorem, already I have given you the idea that we can't apply what? Superposition theorem for power calculation. Okay. Then you have to calculate the, if you have 1 ohm resistor, 1 watt, 1 ohm resistor, right? Then my dear students, you have to find the voltage or what? Current. Then we can add this. So what is the solution for this question? Very simple. First of all, what is the power in first case? Everyone try to understand. It's given by I1 square into R. What is the value of the R? 1 ohm. That is become I1 square. What is the I1 is equal to root over P1. That is root over, not simple, I am going to give you the general answer, root over P1. Similarly, what is the P2 is equal to I2 square into R. R will remain same, that is the I2 square. Okay, and that is the R. R is 1 ohm. So what is the I2 is equal to root over P2. According to superposition theorem, what is the I1 plus I2? That will become root over P1 plus root over P2. Okay. Then finally, what will be the total power? Total power is given by I square into R. Means root over, try to understand, root over P1 plus root P2 the square into R. What is the R? 1 ohm. Remove this 1 ohm. Then what will be the power when I am squaring P1 plus P2 plus 2 times of root over P1 P2. That is the answer for this question. Okay, that will be the answer for this particular question. So what is the P1? 570. I think this is the 576 watt. What is the P2? 1 watt plus 2 times of 576 into 1. Everyone calculate the root of this and give me the answer. What will be the answer for this question? You are not giving the answer. $625 watt. 625 watt. Means if the P1 and P2 is given, you have to use this formula. You have to use this formula. Right? So remember that P1 plus P2 plus 2 times of root over P1 P2. That will be the answer, because the superposition theorem is not applicable for power calculation. We have to calculate the current in individual cases, or you can also calculate the voltage. Okay, then I think that is also clear to you. Now simply, if this question is given, try to understand. Last one on duality. Draw the dual network for the given. Right? If you want to draw the dual of this network, always remember what will be the method to draw the dual of this network. I am giving you the very simple method. First of all, put 3 points here. Let these are the 3 points. How to draw the dual? This is the point 1, that this is the point 2, and this is the point 3. That this is the 3. That is called reference point. First of all, this is a current source. Let this is the value is I. This is converted into a voltage source. Polarity always, this is the plus, this is the minus, that is the, and what will be the value? For example, if it is 2 ampere, that will become 2 volt. Directly, the magnitude will remain same. Now this is the resistor. It is converted into conductance, G. And what will be the value of G? That is same, R1. For example, if it is the 2 ohm, that will become 2 Siemens, 2 mho. This is not resistor, this is the conductance, 2 mho. Then this what? This is the capacitor, this is converted into inductor. For example, if it is 2 farad, it will become 2 Henry in between 1 and 2. This inductor is converted into capacitor. For example, if it is 5 Henry, then it will become 5 farad. And finally, this resistor is converted into conductor. If this is of 4 ohm, this will become 4 mho. This is clear? Now you can draw the diagram here. That is the reference node 3. This is the 1. This is the 2. Between 1 and 2 there is an inductor. The value of inductor is equal to C, that is the 2 Henry. Between 1 and this 2 volt battery, between 1 and this This is a 2 mho conductor. That is the symbol for the conductor and resistor is same. This is the 2 mho. Now this is clear. This is done. Now between two, this is an inductor. Inductor is converted into capacitor. If it is 5 Henry, then it will become 5 farad. Again there is a conductor, that is the 4 ohm. That is called dual of this network. In this way we can find the dual of a particular network. I think that concept is clear. Now tomorrow we have one important session, that complete revision of all the theorems and number of important numericals on theorems like Thevenin's theorem with dependent and independent sources, Norton's theorem, maximum power transfer theorem, maximum average power transfer theorem, right? And we are having very important session on 14th, right, at 10 p.m. Please note the time, that on 10 p.m. we are going to take one important session, right, on your favorite channel. Please subscribe the channel on, right, 14th May. That is, this time the GATE 2023 is conducted by what? IIT Kanpur. And what about the previous paper, and what was the syllabus, right, and what about the pattern? Each and everything we are going to discuss on 14th May. So please note the time on 10 p.m. and tomorrow I am having very important session on all the numericals from theorems. At the same time, if you want to revise some important numericals, if you want to practice some important numerical, then that is the session for you. Okay then, thank you for attending the session. I think you have solved all the assignments on what Thevenin's theorem, Norton's theorem, or superposition theorem, maximum power transfer theorem. Already I have given number of assignments for answer, for PDF, for notes. Join my Telegram channel, that is Electronics by Sanjay Rathi. You are on BYJU'S Exam Prep. Subscribe the channel, like the session and share the link of this session. Thank you very much for attending the session. Thank you.